Okay, more limits algebraically. So when we have h's here instead of x's in number 10, we still have the same math going on. We still have an issue. We can't go ahead and just take that 0 and plug it in. If we took that 0 and plugged it in, our function becomes undefined. So we need to math ourselves, algebra ourselves out of that issue. So here's how I would start. Since I have those equal signs, I'm going to keep the limit notation going until I plug in that 0. The first thing I need to do is 1 plus h squared. Remember, it is 1 plus h times itself. So I need to FOIL that. So that's 1 plus h plus h plus h squared. And then here minus 1 squared, so minus 1 all over h. So I expanded that squared carefully. Still not ready to plug in my 0. Now I'm going to combine my like terms. 1 minus 1 is 0. I can combine my 2 h's. So I have h squared plus 2 h's all over h. And I think it's good in this case to factor out an h before we cancel. That way we make that into a multiplication problem. So h squared and 2h have an h in common. When I take out that h, I'm left with a single h plus 2 on top. And now I can cancel. The other way you could write that would work for you is this. Kind of break it up over that common denominator, and then you can cancel both places, and you come up with the same thing. So however you would like to do it. And just make sure it ends up legal. So the limit as h approaches 0 of h plus 2. And now I can plug in that 0. Now I can take that 0 and plug it in for h. So you just have to be really careful with your algebra. Make sure that you're multiplying out what you need to multiply out. Make sure that you're working carefully and legally. Number 12 is a little different because you have h and x. That means that we may have an x in our answer, and that is just fine. That means our limit is going to look like a line. So our whole goal is still going to be to get rid of that h in the denominator. Since we're approaching 0, h is approaching 0, not x. So this problem is going to work just like the problem above. So since you've seen number 10, go ahead, pause the video, try number 11. You should get 6. So number 11, your answer should be 6. Go ahead and try that one and see how far you can get on number 12 without watching the video as well. All right, so hopefully you gave that a try. I'm going to go ahead and try to catch up with you. The first thing I'm going to do is write out that x plus h squared is x plus h times itself. And that means I'm going to get x squared plus xh plus xh plus h squared. And then I still have that minus x squared. And it's all over h. And then we're going to combine my terms. Again, this looks very similar to the work that we did on number 10. My x's are going to cancel, my x squareds. And I'm going to have 2 xh's. Remember, we don't need to get rid of the x. We're not doing anything with the x. We're just working with getting rid of the h in the denominator. So here's where you have some options. You can simplify from here by factoring out an h. so that you can cancel, or you can simplify from here by breaking up over the common denominator. I think either one is lovely. I would pick what you like and stick with it. So that means our numerator is gone, and our denominator is gone, and our numerator looks like this, h plus 2x. And what we're going to do now is plug in the 0 for our h. Don't be freaked out that you have an x there. Again, that just tells you that the limit to x is a line instead of a specific value. All right, I'm going to do another video for this section for 17 through 20. So you can look for that in the next link. And let me know in class if you need help with any of the problems or two.